Okay, charged particle is traveling to the left with an upward magnetic field. What direction will the magnetic force be on the particle? Okay, so first thing we're going to do is we're going to figure out what right-hand rule it is. So the right-hand rule, number one, is talking about charged particles, are talking about current and fields. This is not talking about current and making a field. It's talking about charge going through a field. So it's not talking about the direction the field it's making. It's talking about the direction of the field and it feels. Okay? So that's the second right-hand rule. So we get our second right-hand rule. We get our finger guns out. Your pointer finger goes in the direction of the charge, thinking about firing out little pew-pew, pew-pew bullets, okay, of charge. Your middle finger is the direction of the field. Okay, it's your trigger. Think about magnetic field is what triggers the force. See what I did there? Okay, and then the force is your thumb. You just kind of got to remember your thumb is the force. Okay. Okay, so it says the charged particle is traveling to the left through an upward magnetic field. So I take my pointer finger and I point left. That's the direction of the charge, so that finger goes left. Now it says the field it goes through is up. So that's my middle finger. So I need to keep my pointer finger left, and I need to move my middle finger up. Okay? So I rotate my middle finger so that it's pointing up. I keep my pointer finger to the left. And now I look at my thumb. What direction is my thumb? My direction of my thumb is forward or away or into the paper. And that's what I would write down here for this one. Just as simply as that, you would just write forward or into the page. Something like that. Okay. What I want you to do is I want you to check your work real quick for 5, 6, and 7, or do 5, 6, and 7 if you need to do 5, 6, and 7 still. So do this to figure out the directions. 5, 6, and 7 are the same idea, except it's different things. So downward magnetic field causes a current carrying wire to feel force to the left. What's the direction of the current? So that one is going to be your thumb and your middle finger given the directions, and you got to figure which direction your pointer finger is in. Okay? So talk about 5, 6, and 7. See what you guys can come up with for those. So if we insert a north pole into a coil of wire, we have to ask ourselves, is the field getting bigger or is the field getting smaller? So north poles produce field out of them. So if you insert a north pole, the field is going to get bigger. You're going to get more field lines going through, not less. Okay? You're going to get more field lines going through, not less. Okay? Because you're pushing them in. So, what direction is the induced field? Lenz's law says the field induced is always opposite of the field change. So if the field change is in, then the induced direction is out. So in what direction is the field act? So you take your fingers. This is the first right-hand rule. So charge, motion, producing a field. Okay? So current is being induced in the wire. It's producing a field. Okay? So your fingers coil in the direction of the field. The field is out. So I need my fingers to point towards me and then curl into a fist. Okay? Towards me and then curl. Your thumb is the direction. Gotcha. That's
last time I left my charger.
It's always something. So current is, or the field is towards you. Curl it. Take your thumb and wrap your thumb and around it like locking in a fist. Okay? What direction is my thumb going? My thumb is going counterclockwise around. So in what direction will the induced current in the field be? It's going to be counterclockwise. Okay, so if it's specific about the direction above, below, left, right, or whatever on the wire, this is how you would set it up. You would draw the field going in this case, the current going in. The field is clockwise. So I look and I say, below the wire, oh, clockwise is left. To the right of the wire, clockwise is down. I want you to try 2, and then we'll talk about 3. So for number 3, 2 wires traveling parallel to one another, both going into the paper. Do they attract or repel one another? Figure out the direction of the field for each in the space between them. Then think about what effect this would have on each other. So both going into the paper. So both are going to make a field clockwise around. And then it says, figure out what the direction is in between them. So one is going up, one is going down. So opposites attract. Likes repel. So like poles repel, opposite poles attract. What we have here is 2 opposite poles. We have field going away from the top, pointing down. We have field going away from the bottom, pointing up. Those are going to be opposites of each other. So those would attract. So the wires would actually be pulled towards one another. And it looks something like this.